Welcome everyone to this third session on Meet the Experts. Today we are talking about the human reference for safe and social driving. My name is Joke Welte and today I'm your moderator. Some remarks before we start. Please put off your microphone and your camera. And if you have any questions during the sessions, we don't have a chat, but we have a Q&A and you can put your questions in this one. We will see it, all the speakers will see it, and at the end of this session, we will have at least 10 minutes to answer as questions as possible, and the rest of the questions will answered afterwards and also shared in the Q&A. Also, the recording of this meeting was shared afterwards with all the registered people. So what are we talking about today? First, my colleague Olaf from TNO will give an introduction on this topic. Then Sjoerd Houwing from CBR will talk about assessing driving competences. Jeroen Hogema will talk about how to quantify competent driving. And Espedito Rusciano from JRC will talk about the perspective of type approval and regulations. Afterwards, Olaf will close this session with a short wrap-up and conclusions, and then we will start the Q&A session. So I would like to give the word to Olaf Optenkamp.
Yeah, thanks a lot, Joke. Actually, we have this webinar series organized around the topic of, let me say that I go to the next slide. So far. Around the topic of safety assessment of automated driving. And we are looking to, let's say, answering the question whether it's safe or unsafe to put a vehicle, an automated vehicle on the road. This automated vehicle has a very complex system architecture, and with the increase of automation, this architecture also becomes even more complex, especially in relation with the interaction with the driver that is there. Of course, the human driver that might be in there, but also the possible robot driver that is taking over some or all of the human driving tasks. And that in that constellation of driving through the world with all its variations. So answering this question, whether the system that is being developed, this automated driving system that is being developed, is safe or unsafe, is the subject of this webinar series. Now, the first question we answered actually in the first episode is what is safety? And usually it's referred to as the absence of accidents and incidents. But in relation to automated driving, we said we need to make a distinction between safety 1 and safety 2, according to Erik Holnagel, that provided this concept in 2015. Safety 1 is more about collision avoidance. So making sure that as few things as possible go wrong. Now, automated driving, we need to succeed under many varying conditions continuously. So the safety 2 perspective needs to be included in this when we talk about safety as well, to ensure that as many things as possible go right. Now, when we talk about safe driving, then we can say we should drive normally. But then, of course, then is the question, what is normally? And at the same time, we want to avoid any, and regulations use the words reasonably foreseeable and reasonably preventable crashes. We also indicate safe driving as being competent driving, or careful, attentive. Words as safe and social driving are being used. And many of these terms deal with the fact that we need to anticipate well to all the different circumstances that we drive into. And if we drive on the road, we also should show predictable behavior and our behavior needs to be acceptable in its context, and that under these large variety of scenarios and conditions that we encounter during operation. Now the question is, who are the better drivers? Is it the human or is it the robot driver? And of course, this is not a very fair question. It's also not a complete question. We do see that there's a lot of differences in between human drivers, not only in their driving skills, but also in their experiences, in their state of mind. So being angry would lead to different driving on the road than being in a very happy state. So deciding what is good or what is better is one of the big questions that we would like to discuss in this webinar of today. And we take there the human as a reference. That's also where the regulation looks into. We look to what would be good human and safe human driving behavior. But that means if we want to compare robots to humans, that we need to quantify in a way safe human driving. And if we have done that, then we also should, in safety assessment, indicate how high should we set the bar? When do we decide that the robot indeed would be a better driver than the human? And that's actually the discussion of today. And I'm very happy to give the word to Sjoerd Houwing of CBR to give the first reflections on that.
Thank you, Olaf. Please, Sjoerd.
So thank
Yes.
you, Olaf. Yeah, sorry about that. Before I start my presentation, I would like to acknowledge the main experts from the CBR who have been involved in our research activity so far on automated driving systems. These are Daniel Heikoop, Eve Jonkers, Alex Akkerman, David Stefan and René Klaassen. So what about the CBR? The CBR is the driver testing agency in the Netherlands. And our main focus with regards to automated driving systems is twofold. On the one hand, we assess the performance of the dynamic driving task for automated driving systems. And we do this together with the Dutch Type Approval Authority, RDW, as part of their official type approval task. But we also focus on assessing the competences of the human driver of automated driving systems that can be switched on and off. Two bright researchers in this field, Solmaz Rasmirat of RDW and Daniel Heikoop of CBR, have organized an expert session previously to discuss the aspects of a good driver. And the result of this session was that there are several aspects to a good and competent driver. So, for instance, roadmanship, and this is the ability to drive safely without creating hazards for yourself, but also to respond well to hazards created by others. But also predictable behavior, anticipatory behavior, social compliant behavior, and defensive behavior are elements. And to master most of these behaviors, learning and adaptability is needed. And this is, of course, what makes the human drivers so special. They learn continuously. And at CBR, we keep this in mind when assessing novice drivers. Furthermore, a human driver is able to make decisions based on situational awareness and contextual understanding. For example, they can decide to drive slower if the conditions of the road are not that well. And the human driver can learn by means of different feedback mechanisms. They receive feedback and adjust their behavior on it. So what about automated driving systems? They have the advantage that they drive according to the rules. They don't drink and drive, they don't drive under the influence, they don't drive while fatigue, and they can respond very fast to events, much faster than humans, as long as they have been programmed to do so, based on predefined algorithms and data. There's no learning effect in their behavior without external updates. So everything the system knows about behavior is based on the data available at the time of programming. Therefore, automated vehicle systems have limited possibilities to adapt their behavior to new and unforeseen situations. And these situations especially occur in the case of interaction with unpredictable human road users with non-rule-based behavior. Therefore, when assessing the performance on the dynamic driving task, higher standards are needed for automated driving systems than when novice drivers are assessed. So, for novice drivers, it is sufficient that they demonstrate a basic level of competence in handling standard situations and scenarios. But automated driving systems must be designed to consistently perform at a high level without the need of continuous learning. This means both higher initial standards and a broader range of testing conditions to match human proficiency and ensure safety. So what about the human driver then? For automated driving systems that can be switched off and on, the human driver is in need of additional competences as compared to a driver of a standard vehicle and compared to a driver with an automation level of 4 or 5. And this is because driving with this kind of automated driving systems will lead to new elements of the dynamic driving task. The most important new elements for this dynamic driving task for the human drivers are monitoring the system and taking over the control of the driving task again. And these new elements will of course not be relevant during the whole trip that the driver makes, but when operational domains of these automated driving systems expand, the relevance of these new elements of the driving task will also increase. So for us as CBR and for our fellow driving testing agencies, there will be a need to gain more insight in the competences needed for the driving with these systems. And these competences are divided over the different levels of the driving task, as you are probably aware of, the operational level, tactical level, and strategical level. And they also can be divided in 3 types of competences: knowledge, skills, and attitude. And to make it even more challenging, there are additional questions that are relevant for us. So for instance, what is the basic level of competences for novice drivers and experienced drivers? Is there a difference between the level of competences between these drivers? But also, are these systems a blessing or a burden for drivers with cognitive and visual disabilities? And how can these competences, the new competences, be trained and tested? So there are a lot of research questions to be asked. And as CBR, we just started a phase with several expert meetings and research cycles to look for the answers to these and other questions. And it will take time to gain the necessary insights for the answers to the insights to these questions. And it feels also a bit like pioneering. But together with you as professionals in this field of interest, and together with our future research partners, we will be able to get all the answers that we need. And by doing so, we will contribute to the safe introduction of automated driving systems on our roads. So thank you for your attention.
Yes, thank you, Sjoerd. Then I would like to give the word to Jeroen Hogema. Oh, sorry, Jeroen. Yes, please.
Yes, thank you and good morning. I would like to continue this set of presentations with our contribution, which is about the assessment of competent driving. Mm-hmm. And there it would be good if I indeed have a setup that works. Yeah, there we are. And therewith, I'd like to start with, again, clarifying or detailing further where competent driving lies on a continuum of the severity of interactions that we have while driving. Olaf already mentioned the topics of safety 1 and safety 2, and essentially that's going directly to the core of what competent driving is. So to summarize on this scale of interaction severity, at the far end, there will be collisions, and the tail of that distribution going to the collisions, that's all about safety 1, that's about collision avoidance. In contrast, the majority of driving that's driving as it should be is, let's say, in the middle of this severity interaction scale. And that is where competent driving is happening. So in the end, if we want to assess if either a human driver or an automated driving system is being competent, it's essentially ensuring that they are within the center of this overall distribution. So that's, let's say, the starting point of the concept of assessing competent driving. Now, let me continue with an analogy. Let's not look at humans and automated driving systems, but let's start with birds, comparing starling and a goose, or geese, if you want to look at several of them. At first sight, you could say, well, they are similar in the sense that they have similar sensors, similar actuators, similar ways of moving through the world, also similar in terms of motion capabilities, including their collision avoidance capabilities. Yet, if you put them out there in the world and up in the air, they behave in a very different way, where, and for both of them, the way in which they move through the world is totally adequate for each of these type of birds to preserve their safety. At the same time, if we think about introducing automation into this world, if we introduce a robot bird and we make it fly like a goose, but we put it within the starlings, chaos will result. And if we take this same idea into the world of human driving, you could say that it's a similar situation in the sense that wherever you look at the world, the drivers will have similar sensors, ways of processing their input, and similar ways of driving through the world. Yet, depending on where you look in the world might be very different. And a specific example, what is considered as totally normal and acceptable and competent driving within, let's say, the city of Lima in Peru, is very different from what would be considered competent and acceptable driving in, let's say, the city center of Utrecht, the Netherlands. So all of this illustrating that to guarantee safety, it's not an absolute given, but it's also about taking competency to the level of the specific location that we are talking about. With this as a bit of background and starting point, it comes down to core questions, but in the end, what is competent driving? How can it be objectively defined? And last but not least, how should we measure it? And for that, in the series of projects that we are working on, we are working with competent driving as being a minimum set of acceptable driving skills, where this set is defined by driving experts. And within our project in the Netherlands, we're working with experts from CBR. So based on, to some extent, local traffic rules and local driving customs. Within our current set of projects, our initial focus is on highway driving. So they were talking about basic driving skills that are about operational control, so inline behavior, speed choice, car following, but also performing lane changes and entering, exiting the motorways. So with those latter elements, it's also about decision making and negotiation. And in the end, assessing the competence of how these basic driving skills are executed is about putting practical constraints on the kinds of behaviors or the input-output relationships as observed from certain drivers in their environment. How we have been approaching this is in a 5-step process, and here they come flashing by number 3, 4, and 5, just like that, as a quick overview of the 5 steps that I will be zooming into in the upcoming slides. Where step number 1 was about collecting information from existing driving manuals from the Netherlands, but also UK, USA, and several other sources. So really studying those documents, but also communicating with the organizations who were responsible of writing them. So for us as a starting point to come up with a set of rules and recommendations that we could work with and use that as input for our second step, which was about assertions. So that's about defining a set of rules that express certain elements of highway driving, formalized in the end, let's say, mathematical formulations that can be checked for being met or not once you have the data that you need to check on them. And one basic classical example is in terms of car following behavior. When in a following situation, you might say, well, we have a 2-second rule. So that's a rule that can easily be expressed as an assertion and then checked on later on if that's being met or not. Our third step was about collecting data of population-wide driving behavior. So here we had drone data collected over a motorway in the Netherlands using video processing to extract trajectories of the vehicles passing by. And from there, collect statistics on to which extent these several assertions that we had drafted were being met or perhaps not in some situations. Our fourth step consisted of really introducing the element of assessing competence of driving using expertise from CBR experts and using that during actual driving, so collecting their opinion on the behavior really on the fly in real time. So we conducted a driving study with a set of participants who were one at a time driving a TNO test vehicle, while a CBR expert was sitting in the passenger seat and using a box with push buttons to mark the quality of the driving throughout the drive. So every couple of seconds, one of 3 buttons could be pushed to mark this driving behavior. As I am observing it right now, it's good, it's competent, or 2, it's, well, not that good, but not that bad, so it's in between. Or category 3 would be, well, whatever I am observing now, there are things going on that I would declare as not good enough or not competent enough. And in our analysis, we matched those button presses to the assertions that we had been collecting before. And to give one example, earlier I mentioned this 2-second rule being element of the assertions. Well, in the end, if you look at the actual car following behavior as it happened throughout our drives, and if you match that to the button presses as we collected them, this graph illustrates that the red markings in the graph that you see, those were declared as being not good enough by the CBR experts. So yes, there is a relationship between following distance and the quality of the driving as it was being assessed, but it's perhaps not so much a strict 2-second rule, but following at somewhat shorter time gaps typically is still considered to be okay. But if you go below a certain lower threshold, then you really get in a region where typically behavior is not scored as being acceptable anymore. Which brings me to step 5 of the overall process, and that's about using all of the elements that we have been collecting, using that in simulation-based assessment, where you could think of starting with simulation results from a virtual world, where you would have a test vehicle, illustrated here on the left by a yellow car that's driving through a virtual world, with an automated driving system being responsible for controlling that vehicle. And from that simulation, you can collect data. And once you have those data, you can extract the portions of the data that can be matched with assertions that we have in our assertion base, and see where in the overall distribution the specific responses ended up. And you can also compare the parameters that you find with the ranges that have been identified as being acceptable ranges based on the work that we have been doing with the CBR experts. And combining that all together would yield in a reporting and advice element on which elements of the behavior as observed in this simulated world do or do not, perhaps do not yet match the what we consider to be competent driving. Well, this concludes step number 5 of the 5 steps that might suggest that we are ready. I can assure you that we're not. As you might imagine, it's typically a kind of iterative process that we are working with, and indeed we are going through a new iteration. And it's good to clarify that when I say we, it's first of all it's the TNO project team, but it's also the Dutch ministry for whom we are working on these projects. And it's also organizations like CBR and RDW who are also helping out in this project in sitting down together and discussing where we stand and how to proceed. So like I said, a next iteration is being conducted right now, which is about fine-tuning the overall methodology and getting to a more complete or assuring the completeness of the assertions as we have them right now. And in this new iteration, we are also aiming on getting more grip on the maneuvering level of driving, in contrast to until now, it's mainly been at the control level. And also taking anticipation explicitly into our assessment of driving competence. Which finishes my contribution to this set of presentation. And this is where Espedito can take over.
Yes, thank you, Jeroen.
So, hello to everyone and good day to everyone. First of all, let me thank you also, TNO, for inviting me to this webinar. I'm excited, to represent the European Commission. Today, I'm going to provide, the overview, mainly to the regulatory, overview on how to assess the driving capability. Before starting with the presentation, I would like just to make, a small disclaimer that whatever I'm going to present, today does not really represent the official position of the European Commission. So now we can start with the presentation. So what we have now in terms of regulation, in particular in Europe, and for type approval countries, we have basically 2 regulations that cover, automated vehicles. One is for level 3 for the ALKS. That is the regulation 157. It's an international regulation. It's not just applicable in Europe, and mainly cover the situation in which the driver is still present, but is not engaged in the driving task. And then we have a dedicated European regulation, that is the regulation 2022 1426, that is for level 4, means fully automated vehicles in which the driver is not present, even though this regulation is covering basically 3 use cases. In addition to that, at international level, we have also some guidelines that were developed in order to cover level 3, level 4, and even level 5. Why it's important also to mention these guidelines? Because these are the starting point to develop a regulation for automated driving system that should enter into the force by the 2026. It will be worldwide, applicable. And I think it will be really, a great achievement. If we look to all these 3 regulations, we will see that they use, for the assessment of the ADS, automated driving system, they use a similar approach that is called multi-pillar approach. In what consists the multi-pillar approach? Basically, there are different validation methods. There is the audit, there is the testing, and then there is the in-service monitoring. Now, in the frame, and if we look in particular to assess the driving capability, I think it's important to highlight that there are 2 elements. One is the real-world testing. So it's important to validate the capability of the system in the real-world condition. On top of that, if we look to the multi-pillar approach, we see that there is also an horizontal layer that is the scenario catalog. Why is important the scenario? Because if we look to the scenario, we see that the evaluation of the driving capability should be done in a different traffic condition. And what I mean with traffic is also including different environmental conditions. Now, if we zoom in particular in the scenario, we will see, and this diagram, I don't want to explain the entire diagram, but I think it's important to highlight some element of this diagram that comes from the European regulation that is mainly in order to develop dedicated scenario to be tested for the automated driving system. But if you look into this diagram, you will see in particular that the diagram mentions 3 kinds of scenario: the nominal scenario, the critical scenario, and the failure scenario. Why it's important this? Because in particular, the failure scenario basically means the situation in which there is a failure in the system. And then when we move to the nominal scenario are traffic situations that are reasonably and foreseeable to happen, but they will not lead to a critical interaction. And then we have the critical scenario that are basically unexpected, I will say, condition that potentially will lead to an emergency operation. It's important to highlight that there are 3 kinds of scenario to explain that the evaluation of the ADS capability will be done in all these conditions. So it will be an extensive evaluation that will not just focus on the critical situation. But if we look in particular now the critical scenario, we see that the critical scenario are often linked and coupled with the safety model. I would like to highlight a few concepts about the safety models. The safety models are used to evaluate the system in critical situation. But in general, if we look from regulatory point of view, we have basically 2 kinds of safety model. One in mainly focus on accident avoidance. And so basically, with this kind of models, we try to distinguish between what is avoidable and what is not avoidable. And then we have the conflict avoidance model that mainly try to define the strategy and the behavior to avoid to be in a critical situation. So they include some anticipation. The current focus is mainly on emergency conditions. So I would say mainly on accident avoidance. If we look, for instance, to the LCAS regulation, we see that for level 3, the model that's often is referred is what is called competent and careful human driver, that basically try to estimate the capability to avoid an accident for mainly CAT-in, using the reaction characteristic coming from the human driver. But now I think one of the questions that we should ask to ourselves, is this sufficient or not? Is sufficient basically to focus on emergency reaction, or we should go beyond? From our point of view, from JRC point of view, the model that just focus on emergency reaction, they have some intrinsic limitation. First of all, they basically divide the area in safe and unsafe. It means that they just apply the reaction or do not apply anything. And this basically means that there is no anticipation, first of all, and then basically sometimes they can be too conservative because they apply always the same reaction. What is important, what we think is important is that we should include, some anticipation. And the JRC proposed, also to have and to include a new model that is called, the fuzzy model, in order to ensure that, for instance, for the longitudinal, behavior, there are also mild deceleration. Before, so basically in this case, and the fuzzy model is based on the fact that we should not just, separate between safe and unsafe area, but we should have a sort of buffer area in which, some mild deceleration are possible. How this kind of model, works? The model is using, fuzzy surrogated metrics, but just to give an idea, basically the model will include, some specific check. One check is on the lateral distance. Basically, the check try to understand whether, there is a vehicle on the other lane, and if this vehicle is coming close to the ego vehicle. And the second check is mainly about, the longitudinal check in order to understand whether there is a risk of collision. And in this case, there are two checks. One, to evaluate whether there is an imminent risk. In this case, the system should, apply an hard deceleration. But if we are in this buffer area, mild deceleration are possible. Why I'm focusing with this fuzzy model? Because I think it's important to explain that the ADS should really, exhibit anticipatory behavior. Is this enough? I will say it's not, sufficient, because when we look to the ADS, we should also try to evaluate the safety in regards to the other road users. The concept of roadmanship. The system should not create any hazard to other road users. Now I'm just showing, you will see in the video, an example of some tests that we have done in US to explain, partially, this kind of concept. For instance, we should take into consideration how the system behaves when there are other road users, also vulnerable road users, for instance, pedestrians. There are some expectations that in that case, the system should behave and should try to mimic also, the good behavior of the human. So in this particular situation, the system maybe should decrease the speed and maybe should also increase the lateral distance. This is also what we have seen, in our test. There are some vehicles that will try to mimic and try to have this good behavior. This is something that should be part of the assessment. I will not go, with the video, because also from the video is not really appreciable, but you can see from the graphic that there is, decrease of the speed when the vehicle is approaching the pedestrian. Another aspect that I think is important to take into consideration is not just about the safety. I will say that when we look to the regulation point of view, and when we look, to the introduction of such system, we should look also on the impact on the traffic dynamics. Okay, this kind of system should not disrupt the traffic. And this is why in the regulation, starting from the LKS, there are some requirements regarding string stability. What I mean with string stability, basically, if there is, a perturbation from a vehicle, from a leading vehicle, this perturbation should not propagate to the other vehicles. We did some also tests with JRC by comparing, the nominal, I will say, behavior of the ACC with the LKS. And you can see, in the graphic on the top left, as the ACC tend to propagate basically the perturbation, while the LKS, will reduce. So it will be string stable. This is really important because we need to ensure that, the traffic efficiency will improve. Now, let me just to conclude, to summarize. When we look to the ADS, we should ensure that the system will drive safely in all the situations, from nominal, critical, and also in failure condition, and should also drive in a predictable and also in a natural way, also to ensure that, will not will not create hazard to other users. But in addition to that, we should also look to the traffic and environmental efficiency. With that, I have concluded my presentation. But before finishing, I would like just to thank you also, the JRC team that, supported me with this presentation. Thank you.
Yes, thank you, Espedito. So that brings us almost to the end of this presentation, and we will go to Olaf, who will give a short summary.
Yeah, thanks a lot, Thanks a lot to you all. There have been many topics around driver competence being discussed. Let me reflect on some of them. Oh, actually, I have been learning a lot today. We talked about training and assessing skills and capabilities of human drivers. How do we do that? We need to do that if we want to take the human as a reference also for automated driving. The topic of mixed fleets was mentioned. So how do we deal with the traffic system and with assessing the traffic system is if part of the fleet is automated and a large part currently at least is not. Then Jeroen indicated how to quantify competent driving behavior and how to use, for instance, traffic rules into that approach, indicating also that there are more iterations needed to bring that to the full scale of driving. And of course, that brings us also to considerations on setting the bar for automated driving. If we are able to quantify a competent and careful human driving, then we can use that to set the bar for automated driving. And then finally, Espedito put that in the context of the regulatory framework and indicated also some additional aspects that we need to consider, not only to just check safety for different type of scenarios that are out on the road that we might encounter, also make sure that systems anticipate well, but if they anticipate, that they don't disrupt the traffic system. So it's more than just safety. We already concluded in earlier sessions that safety is a very broad concept, and today the complexity was increased. However, I think also that this session brought a lot of insights on how to deal with that. And therewith, I would like to go back to you, Joke, to start the question and answering session.
Yes, not today. The recording will be shared afterwards. Also, the answers to all your questions in the Q&A will be answered afterwards and be published in the Q&A session. If you think this is very interesting and you also want to join our next session about the AI, the solution and the challenge, please register yourself again. And we hope to see you again on the 11th of July. Thank you very much. Goodbye.
Yeah, thanks a lot to all. Bye-bye.
Bye-bye. Thanks a lot.